Okay. So today we are going to be going over plate tectonics. There's three main types of boundaries that you need to be familiar with. Don't write these down yet, but you will be soon. It is divergent, transform, and convergent boundaries. It's the three. What we're working on today is 8.9b is the TEK. It's called crustal movement. And you can see from what we have up here, those are three big vocabulary words. When you think about converging, for example, when I coached football, we would tell, when I was coaching defense, we want 11 hats on the ball, converging on the ball. We want 11 people destroying and trying to kill the person running the football or trying to throw the football. That's, we're converging on that. And then when you think about the word diverging, the movie Divergence, the sad state of affairs with relationships, divorcing, means to go apart, spread apart. So that's what happens with the land masses, they move apart. And then the other one would be a transform boundary. How I like to remember it is, there's a guy named DJ Earthquake, one of my favorite DJs. He would go back and forth on the ones and twos and do a lot of scratching. He works a lot of hands on the Techniques turntables, makes a lot of cool sounds, and that's how I remembered that transform boundaries moved side to side to give me earthquakes, because that's really the big thing that happens at a transform boundary. San Andreas Fault would be the best example of that. It's the most studied boundary, transform boundary in the world. So those are the three. We're going to start with the divergent boundary, so you can go ahead and write divergent down, divergent boundary. So we're going to talk about what it is and the types of things that it does. Let's look at this picture. Here we're on the... If you go into Google Classroom and you open up divergent and transform boundary PowerPoint, we are on slide 1. And as you can see here, we talked about this before. As we have a divergent boundary, Harry Hess was looking at the ocean floor, and he found this mountain range, and they took samples, core samples, and they saw that at the ridge where the magma comes up is the newer rock. And as the plates move apart from each other, the age of the rock gets older and older. And so that's kind of what's happening. Best example, Mid-Atlantic Ridge in the Atlantic Ocean. The ocean is now wider today than it was when you were born because it is moving apart. And the land masses used to be together in Pangea, but now they are moving around and drifting like Wegener said. And you can see here in this picture, we have your ridge, we have the asthenosphere and the melted molten magma coming up, cooling and becoming new land. So a divergent boundary makes new land. Iceland is diverging. They have this big ridge going here, this depression. The water, the ocean water, eventually is going to make its way in there, become a stream, and then keep widening. Kind of like the Red Sea. Used to be a lot smaller, but that's on a divergent boundary. So when Moses parted the Red Sea back in the day, it was much smaller then than it is now. And it was much smaller than that many, 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 many years before that. But it keeps getting wider and wider, and eventually, the Red Sea could potentially become the Red Ocean because of the way the plates are moving apart. So underwater, we call it a mid-ocean ridge. But if you have divergence happening on land, we call that a rift valley. I'm going to talk about that in a second. Let's take a look at this video here.
Hi, it's Mr. Anderson. Today I'm going to be talking about plate tectonics. What's always interested me about plate tectonics is it's a fairly recent science. In other words, not until the 1950s were we sure that the plates were actually moving. One of the first people to suggest that was Alfred Wegener, and he actually worked right around 1920. And what he said is that if you look at the different continents, here's North, South America, Africa, Eurasia, they tend to fit together on almost like a puzzle.
So we did talk about that, or we did discuss that yesterday, especially in the video that we watched. What I want to do is I want to move this forward to this right here, because this is the information I want you to pay more attention to right now.
Hitting an oceanic plate, the one that's more dense is going to be the oceanic plate. And so the oceanic plate is going to be forced underneath the continental plate. And so a great example of this would be on the west coast of the United States. We have this, which is the Pacific plate, going underneath the North American plate. And so this would be that dense oceanic crust being pushed underneath the continental crust. And as it does that, it starts to melt as it moves farther and farther down, and it eventually causes volcanoes. So Mount Rainier is an active volcano. Mount St. Helens is an active volcano. And why is it active? It's because the oceanic crust is being forced underneath the continental crust. It's melting, and then it's causing that volcanism on the surface.
Okay, so that is an example of, do you think that's divergent or convergent? Convergent, good. You can see the two plates coming together. Always one subducts. You can take this to the bank. The wet plate always subducts. So if you have a dry plate, which is continental, and then you have oceanic plate, the oceanic plate is so full of water. It's got the ocean on top of it. And we all know how heavy water is. When you try to carry like things full of water, it's ridiculous. So I mean, everyone's experienced that. If you've lived on planet Earth for any period of time, you know how heavy water can be. So that's the reason why that oceanic plate is so heavy, because that water has really drenched the top portion of that plate, making it heavy. And so what's more dense sinks. So the more dense plate will subduct. And that is a fact as far as plate tectonics is concerned. Now, if you have convergence with two oceanic plates, the one that is more dense is the one that will subduct. So if it's continental and oceanic always subducts. And if it's oceanic and oceanic, the more dense oceanic plate will subduct. Let's keep moving here. Okay. So we already talked about that. When two things spread apart, we say they're diverging and that they're moving away from each other. You can see the little arrows here for the divergence. This would be an example of mid-Atlantic ridge right here. So there, as you can see, there's a sliding of the plates going side by side. That's why that line here says transform boundary, is because the plates are actually sliding. Those two plates are sliding while they're diverging. Sometimes those things can happen. Divergent boundaries are mostly found at the bottom of the ocean. And that's how Hess connected the how that Wegener was missing, which was sea floor spreading. That's what they called this divergence on the sea floor. Sea floor spreading. As tectonic plates move apart, magma pushes up along the boundary. This creates large underwater mountain ranges. Nothing new here. Now, this is the one I really wanted to pay attention to, and I brought it up earlier, which is, what if the rifting happens on land? Not in the ocean. What if it happens on land? There is an area in Africa where this is happening. It's called the Great Rift Valley. It's on the northeastern part of Africa, and it is spreading apart. It's kind of like if you take a Snickers bar and you start to pull it apart, it becomes thinner in the middle. and it starts to have a depression. Okay? So eventually, right here, it's going to get to the point where water will be able to start coming in and create that streaming and then create rivers and whatnot. So, because as it keeps getting lower and lower, we know where sea level is, and once that depression is lower than sea level, that's when the ocean starts making its way in there, and eventually it will separate, and Africa will look different thousands and thousands of years from now. The magma is pushing up along this divergent boundary, also tends to lead to volcanic activity. There can be volcanoes at divergent boundaries. There can be. As magma pushes up and hardens into new rock, it creates new crust. And how this is happening and how this movement is happening is as the currents, there's currents underneath in the magma's moving, and the direction of the movement of the magma is the direction that plate is moving. So as the magma's coming up, it's moving like this. And so that's the reason why the plates are pulling in the direction that they're going, is because the magma is driving them. The movement of the magma drives the plates. So the two things, to sum up divergent boundary, you have underwater, you have the Mid-Atlantic Ridge, and then on land we have the Rift Valley. And divergent spreads apart. So if you look over at the teak that I have on the paper, as long as you have those notes and you have the direction of the arrows and how it moves, you're good for divergent boundary. Those are the keys you need. So now we're going to talk about transform boundary. There's not a whole lot to talk about with transform boundary. They're not moving apart. They're not coming together. They're simply sliding past each other. So the San Andreas Fault I brought up earlier, one plate is moving down, the other one is moving up. And that's the reason why they are hypothesizing, if it continues to go in the direction that it is, LA will be near San Francisco. That's the way it's kind of set up right now. If it keeps sliding like it is, LA will be next to San Francisco. And as those slides happen, the friction builds up, boom, and it pops. That's what creates those big, big earthquakes. So again, transform boundary is when two plates slide past and rub against each other. And as they do that, causes earthquakes. Again, you can, and this is a great graphic that shows you what I was talking about, how LA, this whole land piece in California is going to keep moving northwest and then putting LA near San Francisco. Sometimes faults can absolutely be seen. Look at this fault line. So at transform boundaries, where like divergent boundaries, new land is created, transform boundaries, no land is created or destroyed. They're just simply sliding past each other. No magma's coming up. There's no volcanoes in these areas. It's just sliding. So now we have divergent and transform. We are going to talk about convergent boundaries now. There's a lot of examples of what convergent boundaries can do. So when two things come together, we call them converging, just like I talked about earlier with the defenders converging on the football. The first one we will talk about is continental convergence. When we saw that graphic of Pangea separating and India coming up and smashing into Asia, that is continental convergence in the best example on planet Earth, because that convergence is shown right here on the screen, and it created the Himalayan mountain range that continues to grow today. As two continental plates come together, they create mountains. They don't create volcanoes. And I'll explain about volcanoes in a little bit. They like to say that the plates fold up and crumple into mountains, as you can see here. And still there is some subduction, but not as much as there is when wet plate, oceanic plate, is involved. There is some subduction here, but the reality is, look what's happening. It's crumpling up. This material is moving upwards, creating these really high mountains. But there is some subduction here. Earthquakes are common at convergent boundaries, but earthquakes are more synonymous with transform boundaries. Volcanoes can happen at divergent boundaries, but they are more synonymous with convergent boundaries. So there are little videos within here that you guys can watch. I recommend that you do. We just don't have time for it today. I want to go over the concepts and vocabulary words. Again, one plate is much more dense than the other. The plate that is more dense will sink, and that is always the oceanic plate. Now, this is how I like to describe this. Wet plate does not get digested very well by the earth. So as that wet plate comes down and subducts, magma comes up, and these mountains become volcanic mountain ranges. You can see it every single time. Every single time. So here, the great example would be the Andes Mountains in South America. The oceanic plate, it's convergence. The oceanic plate subducts, creates the trench, and the mountain range, the volcanic mountain range, happens. So whenever you have convergence, think STVs. Subduction, trenches, volcanoes. STV. Subduction, trenches, volcanoes. So the definition of subduction is a dense tectonic plate sinking under another and getting destroyed. So divergent plate creates new land. Transform doesn't create nor destroy. Convergent destroys. So if there's a new land being created somewhere, elsewhere it's being destroyed at a convergent boundary. Subducted, brought back down into the mantle, continuing the rock cycle. Of course, subduction happens at a subduction zone. Subduction causes a gap to form along the crust. This gap is deep, creates trenches. Talked about that, how there's crazy animals that live down in those areas, crazy organisms. They look really crazy. It's super, super deep. The deepest areas in the ocean are these trenches where there is subduction. Deepest part of the ocean. Mariana Trench. And I talked about it earlier. As the dense plate melts, as it subducts, it comes up, called magma. And again, creates mountain ranges. They like to call them the volcanoes formed at a convergent boundary. They call them an arc. But the one that you want to see the most, and this is what I definitely want to show you here, when two oceanic plates come together, so now we have oceanic convergence, it creates a volcanic island arc. So the two wet plates come together, one subducts. As it subducts, that magma comes up, and it really creates these underwater volcanic mountains, and then at some point, they start popping out of the water, and those become islands. So the three types of convergence are continental, Himalayan mountains, continental oceanic, like the Andes Mountains in South America, and then oceanic, like the Aleutian Islands off of Alaska. Convergence creates STVs, subduction, trenches, volcanoes. When two plates converge in the ocean, the volcanoes formed can create islands. This island arc here is a good example of that. Look at this right here, oceanic plate, converging, creating that arc. That's it, guys. Thank you.